Now it's time to move on to the backward selection. So, a backward selection is a wrapper type feature selection method that aims to identify the most important features by iteratively removing one feature at a time based on a selected evaluation criterion. It starts with the full set of features and gradually eliminates the least significant features until a stopping criterion is met. So let's look into the uh, definition and explanation of backward selection first. So backward selection starts with all the available features and progressively removes one feature at each iteration based on a predefined evaluation criteria. It repeatedly fits the model and evaluates its performance after removing each feature. So the feature with the least impact or contribution to the model's performance is eliminated until the stopping criterion is satisfied. Next, applicability. So backward selection can be applied to both single sample and multi-sample data. It's widely used in situations where the goal is to identify the most important features that contribute to the predictive accuracy of a model. So then we will look into the mathematical equation of it. So the mathematical equation or formula for backward selection is not fixed since it depends on the chosen evaluation criterion and the specific model being used. However, the general idea is to iteratively remove one feature at a time and evaluate the model's performance after each removal. Next, let's look into the algorithm working process. So, the algorithmic steps for backward selection are as follows. The first one, the step one of algorithm, backward selection algorithm is it start with all the available features, then fit the model using the current set of features, evaluate the model's performance using the selected evaluation criterion, then remove the least significant feature based on the evaluation criterion, then repeat the above steps until a stopping criterion is met. Example, reaching a specified number of features or a desired performance threshold. So now let's look into the applications in where all fields it can be applied, the backward selection for the feature selection. So backward selection is commonly used in machine learning and data analysis tasks to identify the most relevant features for modeling and prediction. So it can be applied in various domains, including the first one is predictive modeling. So in predictive modeling, identifying the key variables that influence the outcome of a prediction task. And obviously in feature engineering, the feature selection, selecting the most informative features for subsequent feature engineering processes. Then dimensionality reduction, simplifying the feature space by removing irrelevant or redundant features, and that's where this one will be useful. So let's see some of the tasks or activities where this can be directly applied, or some of the projects where we can use it. Real life examples of real world project examples. One is medical diagnosis, so identifying the most important symptoms or biomarkers for diagnosing a specific disease. And second one is credit risk assessment, determining the critical factors that contribute to the production of credit default. Then we have the most important one, image classification, selecting the most informative image features for accurate classification tasks. And the last one, customer churn prediction, identifying the key factors that drive customer churn in a subscription based business. So overall, backward selection is a powerful feature selection method that systematically eliminates less significant features, providing a subset of features that are most relevant for building accurate and efficient predictive models.